In this video, we are going to talk about graphing logarithmic functions where the base is a fraction between 0 and 1. So our emphasis today is going to be on a function such as the one shown here. Recall that when you talk about the base of an exponential function, shown on the left in pink, or a logarithmic function, shown here in white, the base is limited to between 0 and 1, such as positive 1/3, or greater than 1. It could be a fraction as long as it's greater than 1. It would be in this area here. The base for either an exponential or logarithmic function cannot be negative, cannot be 0, and it cannot be 1. Now, when the function has a base greater than 1, okay, you are allowed to use this intuition to predict where this graph is going to end up. So here, if the base is greater than 1, this graph is going to tend towards the area where x is negative and y is positive. And that is none other than quadrant 2. So this graph end behavior is going to head towards that quadrant. However, things change when you have a fractional base. Again, the base has to be between 0 or 1 or greater than 1. In this scenario, when you see a base that's a fraction, this graph is going to tend towards where x is negative, but y is the opposite of what you see. So this particular graph is going to tend towards where x is negative and y is negative. And that is going to be the fourth quadrant. So this graph is going to tend here eventually. Okay, let's look at this on Desmos. And here we go. Let's look at these individually. Let's see if I can blow this up a little bit. Okay, I hope you could see that on your screen. But on the top, we have log to the base 3. There's a positive in front of the log. That's associated with the y coordinate, and a negative with the x. As long as that base is greater than 1, you just follow what the signs say. So this graph is going to tend towards where x is negative and y is positive. So that's going to be quadrant 2. And there it is. Down below, you have a fractional base. Again, has to be greater than 1. Here, the x is negative, the y is positive. This graph is going to tend towards where x is negative and y is negative, the opposite of what you see. Negative and negative, and that is going to be quadrant 4. So you can see the blue graph with the fractional base, the y is flipped in terms of using intuition to predict where this graph will go. Let's now go ahead and graph this parent function with a base of 1/3. And if we look at the intuition of this graph, we have a positive x and a positive y. Therefore, because of that fractional base, we're going to expect this graph to head towards where x is positive and y is negative. So that's going to be quadrant 4. Recall, when you have a parent function, meaning no transformations, you cannot even have a negative. That's a transformation. When you have this scenario with a parent function, you're going to have a vertical asymptote at x equals 0. And you're allowed to use these 3 points. 1 over the base comma negative 1, 1 comma 0, and the base comma 1. So let's go ahead and look at that. If the base is 1/3, then you're going to have 1 over 1/3. That's 1 divided by 1/3. And we're going to use keep change flip. So that's going to be 3. So our first point is going to be 3 comma negative 1. So let's put that about right here. Next, we're going to have the point 1, 0. It's going to be here. And then we're going to have the base comma 1. So 1/3 comma 1 is going to be like so. And this graph is going to hug the vertical asymptote, and then it's going to head towards quadrant 4. So let's look at Desmos and see if that's what we got. Here's our function in black, y equals log with a base of 1/3 to the x. And we have these 3 points, 1/3 comma 1, 1 comma 0, and 3 comma -1. Let's now graph this function, and we notice that the base is a fraction. Therefore, when we do our intuition, when we're trying to predict where this graph would end up, we're going to look at the x value and we're going to take that negative. Then we're going to look at the y value, we're going to take the opposite. So this graph is going to tend towards the quadrant where x is negative and y is positive, and that is going to be quadrant 2. So it's going to start at its vertical asymptote and head towards quadrant 2. That's the intuition on this graph. Okay, now previously, when there are no transformations, we use the technique where we have 1 over the base, comma, -1, 1 comma 0, and the base comma 1. We did that on the most recent problem. But there's tons of transformations here. Even if all there was a negative sign, that's a transformation. You cannot use the technique I just described. So we're going to use a different technique. And in this technique, we're going to set the argument to 3 things. We're going to set this argument to 0. That's going to give us our vertical asymptote. Then we're going to set it to 1. And then we're going to set it to the base. And we're going to solve for x each time. So here we're going to get -x equals -2 or x equals +2. That's going to be our vertical asymptote. So let's go ahead and draw that in here. So the prediction is that this graph is going to start at the vertical asymptote and head towards quadrant 2. Let's see if that happens. Here we're going to solve for x. We're going to get -x equals -2 plus 1, -x equals -1, x equals +1. Now what we're going to do, folks, to get our y coordinate is we're going to do f of 1. So when we plug 1 into our original equation, we're going to get -2 log to the base 1/3 of -1 plus 2. -1 plus 2 is +1. The log of 1 is always going to be 0. So this whole result is going to go to 0. So our next point on this graph is going to be x equals 1 and y equals 0. Let's go ahead and plot that right now. Right there, 1, 0. Now we're going to get our third point, and that's really all you need. You need a vertical asymptote where we start and 2 points, as well as the intuition of where we're going to end up. So here we're going to have -x is going to equal 1/3 minus 2, which is going to be 1/3 minus 6 over 3. And we're going to end up with x equals +5 over 3. We're now going to do f of 5 over 3. When we plug f 5 over 3 here, we're going to get -2 log to the base 1/3 of -5/3 plus 6/3 equals -2 log to the base 1/3 of 1/3 to the first power. And folks, recall, whenever you have the base matching the argument, these cancel out and you get the exponent. So this is going to result in -2. So our next point is going to be 5/3, comma, -2. So that's going to be roughly right here. So our graph is going to start at the vertical asymptote. It's going to go through the point 5/3, comma, -2, and it's going to come this way towards quadrant 2. Let's look at Desmos and see if that's what we get. And it is indeed what we get. Here is our vertical asymptote at x equals 2. Here's the point 5/3 comma negative 2, and here's the point 1 comma 0. Excuse me. Now, if your teacher asks you to get the y-intercept, let's talk about how to do that. Recall that the y-intercept is where x equals 0. So if you plug in x equals 0 here, you're going to get negative 2 log base 1/3 of 2. Log to the 1/3 base is not calculator friendly, so we're going to use the change of base formula. We're going to put log of 2, log of 1/3, and we're going to choose a base of 10. And when you plug this into your calculator, you're going to get positive 1.26. So our y-intercept is going to be 0, positive 1.26, and that is indeed what we have here. Let's now graph this last function. We notice that we have a fractional base. Therefore, the the end behavior is going to head towards where x is negative and where y is negative. Again, we take the x sign at face value and we take the opposite of what we see for the y sign. So if there's a plus here, which there is, this graph is going to head towards where the y is negative. So where are the x values negative and the y values negative? Quadrant 3. Let's go ahead and find our points. Again, because this is not a parent function, we cannot use the technique that we did at the very beginning, where we had 1 over base, comma, negative 1, etc. So we're going to do 3 things. We're going to set this argument to 0. That's going to give us our vertical asymptote. We're going to set it equal to 1. And then we're going to set it equal to the base. Okay, if we set it equal to 0, we're going to get negative x equals 1 and x equals negative 1. Folks, that is our vertical asymptote. So let's go ahead and draw that in. So our prediction is that this graph is going to start at the vertical asymptote and it's going to head towards quadrant 3. Let's proceed. If we set the argument equal to 1, we're going to have negative x equals 2. Therefore, x equals negative 2. We're now going to do f of negative 2. If f is negative 2, we're going to have log base 1/5. If x is negative 2, we're going to have 2 minus 1, or 1. Whenever you have 1 in the argument, the log is 0. So we're going to have x equals negative 2, y equals 0. That's our second point. Here, we're going to have negative x minus 5 over 5 equals 1 over 5. Negative x equals 6/5. X equals negative 6 over 5. Now we're going to do f of negative 5 to get our second point. I misspoke before. Negative 2, 0 is our first point. So if we do f of negative 6 over 5, we're going to get log base 1/5. If we plug in negative 6 over 5, that's going to end up being positive 6 over 5 minus 5 over 5, which is 1, and we're going to have this scenario again. See, folks, this is by design. Setting it equal to 1 and the base makes your math easy. So our second point is going to be negative 6 over 5, comma, positive 1. So let's go ahead and plot those points. we're going to have, here's negative 1 on our graph right here. So our first point is going to be negative 2, 0. Let's put that out here. And then we're going to have negative 6/5, comma 1. That's going to be right about here. So our graph is going to hug the vertical asymptote and head towards quadrant 3. Let's see what Desmos says here. And there it is. Here's our point, negative 2, 0. Here's our point, negative 6/5, comma 1. And here's our vertical asymptote at x equals negative 1. Now, what if your teacher wants you to do the y-intercept? So the y-intercept here, we would set x equal to 0. So let's do that and see where that takes us. We're going to have log to the base 1/5. If x equals 0, the argument becomes negative 1. Now, folks, you cannot have a negative argument. All right? Remember the restrictions on the base for both exponential and logs. This has to be positive, and it cannot be 0, and it cannot be 1. For the argument, it has to be positive. It cannot be 0, but it is allowed to be 1. So the argument's a little bit more lenient, but it definitely can't be negative. So that means this does not exist. And you see, if you look at Desmos, that makes sense, because here, this graph is now hugging this vertical asymptote. It is never going to cross the y-axis. And just in case, if you want to plug this into Mathway, which I did, here's our function, original function, log to the base 1/5 with the argument negative x minus 1. And I asked for the x and y intercepts, and here it says y-intercept none. X-intercept negative 2, 0, it's right there, but y-intercept doesn't exist, and that's because when you plug in x equals 0, you get a negative argument.